Introduction to weathering. Weathering is the breakup of rock. Erosion is the transport of weathered material by wind, water, ice, or gravity. The material is called sediments. Sediments are any particles or materials formed by the breakdown of rocks or organic materials. First, rock is weathered into smaller pieces. Then those pieces are eroded, moving to a new location. And then finally the sediments are deposited somewhere else. This is going to discuss the first step, weathering. There are two types of weathering. Mechanical, breaking a rock into smaller pieces. I usually picture a hammer breaking something mechanically. Or chemical, process where the rocks are decomposed or dissolved. Some sort of a chemical reaction is taking place, changing the material, not just breaking it. Mechanical weathering has several different forms. First, we have ice and water. It's called frost action or frost wedging. Water slowly seeps into cracks in the rock, freezes, and then expands, just like sticking a can of Coke in the freezer. It breaks the can. In this case, water seeps down into the rock. You can see the snow here. Water seeps in, freezes, breaks it open, thaws, seeps in deeper, freezes, breaks it open. This slow process, starting from a tiny little crack to a huge one. This is especially big in the springtime when you start seeing the roads look like this. This is from frost action. Water gets down into the concrete, freezes, and then breaks it open. You can see it in sidewalks. You can see it happening under the ground in this case. And it also causes burst pipes in your house. The ice freezes in the pipe, expands, and blows it out. Abrasion is the next type of weathering. It's when wind-blown sand or moving water or ice rubs against the rock, wearing away or breaking off pieces of rock. In this case, it would be sandblasting. The wind carries sand that eats away at this sandstone in the desert. More abrasion tends to produce rounder, smoother rocks. Think of river rocks. If you've been in a river, you see the water, especially at flood stage, rushes over the rocks and smooths them out. They roll against each other and become rounder and smoother. The Leaning Tower of Pisa, you can see this staircase looks kind of like someone sat their butt in wet cement, but they didn't. Footsteps over hundreds of years wore down the material by rubbing. Desert pavement, the wind blew away the surface and slowly packs it down. Also, plants and animals can cause weathering. Plant roots are a big one. They enlarge cracks in the rock, increasing the surface available for other types of weathering. Digging animals expose bedrock to air and water. This is an image of at Difficult Run in Virginia, a little stream that flows into the Potomac River. We've got a tree here with its roots wrapped around a boulder, and you'll notice the tree is not right side up. What happened was something like this. The tree was sitting on top of a cliff. Tree roots grew into the cliff, and then grew even more, digging into the cliff until eventually they break the boulder right off the side of the mountain. So this tree started out at the top of a cliff, vertical, and ended up at the bottom. Exfoliation is another option. Rock being lifted up to the surface. Granite is one that this happens a lot too. It formed deep within the earth, so is used to a great deal of pressure. When it comes up to the surface, the pressure is released, and it starts cracking off in these layers. This is exfoliation. If you've ever exfoliated your skin, you're taking off layers of dead skin. This is layers of rock. What happened is the rock formed deep underground, and then is slowly exposed and releases the pressure, producing this rounded dome shape. Dome mountains. And then the pieces break off, expand, and slide down the side, leaving these crumbled pieces along the sides. Again, it came off in layers. Stone Mountain and Independence Rock are good points of this. So that's mechanical weathering. Next we're doing chemical weathering. There's two major types, acid rain and oxidation. Acid rain uses a process called hydrolysis. Calcite is usually the mineral that it's being reacted to. Water and carbon dioxide, just normally in the air, or sulfur from volcanoes or factories, produces acid rain, and it dissolves calcite. This is an image of acid rain formed from human activities, car exhausts and the like, and factories leave sulfur and nitrogen and produce acid rain, though it does happen naturally as well. Effects of the acid, well, here's a marble statue in a cemetery. You can see she was most probably not carved like this. This cracking and peeling and dissolving look on her face is due to acid rain. Over here we have a concrete wall. It's very old, and groundwater flows through it, dissolves the concrete, and then leaves these like mini stalactites hanging down the side of it. What they have in common, marble and cement, calcite. And then we've got oxidation. This is when iron-bearing materials in rocks react with oxygen in the presence of water to form rust. You're familiar with rust. Here, if you notice this dirt, this is dirt along the side of the bank of Difficult Run here in Virginia. The dirt kind of looks a little rusty. It actually is. The natural rock in this area is schist, a metamorphic rock. It's glittery. We usually talk about shiny schist. But it has a good deal of iron in it. And when you allow time to go on, that iron oxidizes, and so you get these rusty look over time. And that breaks down, and this is how soil is created, given a few thousand years. This is just two different rocks at different points in their creation or destruction. Here, take a good close look at this picture. What's going on? Looks pretty boring, but look a little bit more closely. This is a sign at the parking lot in a nearby school. Look really closely, right here. See? The tree is grown around the sign. It's obviously been here for a while. So what we have is two things going on. Mechanical weathering, the tree is literally breaking the sign in half, and chemical weathering in the form of rust is destroying the sign as well. The rate of weathering, how fast it happens, depends on the surface exposure, mineral composition, and the climate. So weathering takes place on the surface, so the more surface that is exposed, the faster it will weather. So here, we only have a certain amount of surface available. When you break it up into smaller pieces, more surface is available, and more the smaller the pieces you break it into. Smaller pieces erode or weather much more quickly. This would weather much more slowly because it has much less surface area. Mineral composition is also important. For instance, quartz, sand, glass. It's resistant to chemical weathering. That's why we use glass bottles to hold our acid. But slow mechanical weathering breaks it into sand. Anybody who's ever broken a glass knows that it breaks pretty easily. Calcite, though, is pretty strong. It doesn't break very easily. But, as we've seen from the marble statue and cement, chemical weathering turns it into clay. So, in an arid or dry climate, quartz, like sandstone, gets eroded very quickly, and calcite, like marble and limestone, erodes slowly. In a wetter environment, quartz is strong, but the calcite and marble, very poor choices. So warm and wet climates favor chemical weathering, like acid rain and an oxidation. Cold or dry climates favor mechanical weathering, like wind abrasion, frost. And frost action works best in areas with large temperature variations. You're going to want some moisture, but also you want the temperature to change a lot. Just like in spring, lots of rain, hot, cold, hot, cold, hot, cold. So in this image, we've got some rock. It started out filled to the top, but now it's been worn down. Notice the blue has been weathered a lot more than the orange. The orange seems to have been very resistant. So if this is a humid climate, would the blue, more weathered rock be quartz or calcite? If it's humid, then that means chemical weathering is going to be very strong. So the calcite is going to be more dissolved. But if it were a dry climate, calcite's tough. The quartz, though, would be susceptible to mechanical weathering in an arid climate.